Today in our lesson we're going to talk a little bit about how to combine the Boyle's law that we've already learned about and Charles' law, which we've already learned about, and turn them into just one equation. And when we do that, we're going to call that the combined gas law. This is going to be a pretty quick video. Shouldn't be too difficult for you, but we know that we've learned about Boyle's law, we've learned about Charles' law, and so we're going to be able to take those two and convert them into just one equation, and then we're going to do some math with that equation and make sure we can solve for our unknown. So as we've already learned, Boyle's law is P1 V1 equals P2 V2. And as we know, pressure and volume have an inverse relationship. When one goes up, the other one goes down. And then with Charles' law, we've learned that V1 over T1 equals V2 over T2. I would make sure I'm writing this information down in my notes. And then you'll notice that the things that these two laws have in common are the volumes. And you'll notice that there's a V1 and a V2 in both of these laws. So basically what we can do is we can kind of put those two together, and so you can probably already kind of start to see it here. If you put P1 and V1 together on the top and then have T1 on the bottom, what you end up with is you have an equation that looks just like this. So the initial pressure of the gas times its initial volume divided by the initial temperature is equal to the final pressure times the final volume divided by the final temperature. Just like in Charles' law, this temperature in both cases must be in Kelvin. Nothing new there. But what's kind of neat about this is this is basically Boyle's law and Charles' law together. And what I mean by that is, if we look at this bottom part, it says if any part of this equation is constant, which means it doesn't change, you can remove it. So what I mean by that is, let's say we're reading a problem and the problem says at a fixed temperature or at a constant temperature, the pressure does this, the volume does this. Well, then basically you just take the temperature out of that equation and now it just becomes Boyle's law. If you're doing a problem and it says something about the fact that the pressure remains constant, so the temperature of a gas does this, the volume does this, but the pressure is constant, then you take the pressure out. And now you've got V1 over T1 equals V2 over T2. So not only is this a good equation to know because it's an important equation, but it's basically all the laws that we've learned so far all combined into one. It's Charles' law, it's Boyle's law, and obviously it is the general gas equation. Sometimes we call it that, sometimes we call it the combined gas law as well. One equation which we actually didn't talk about but also is valid is, what if you had this, again, something like this, but then the volume remained constant? If our volume is constant, then the volume can actually be removed, and so we have an equation we actually haven't seen before where we have P1 over T1 equals P2 over T2. Now that makes sense. Let's think about that, even though we're not even going to give this one a name. Let's think about what that means. It means that if the temperature of a gas goes up, but the volume can't change, then the pressure inside will also go up. And that obviously can be potentially dangerous. If the pressure gets high enough, the container that it's in can sometimes explode. So we've actually got this one great equation, this combined gas law or general gas law equation, that will allow us to find many different things depending on the information that they give us. It's really important that we read and understand really well what is it that they're asking us for when we're solving one of these problems. So let's take a look at one. It says a fixed quantity of a gas at 23 degrees Celsius exhibits a pressure of 748 torr and occupies a volume of 10.3 liters. So the first question says, calculate the volume the gas will occupy at 23 degrees Celsius if the pressures increase to 1.88 atmospheres. So a couple things we should realize right away. 23 degrees Celsius, 23 degrees Celsius. What's that telling us is that the temperature is not going to change. So let's come back here So P1 V1 over T1 equals P2 V2 over T2. If the temperature does not change, the temperature is now out, so it's just P1 V1 equals P2 V2. So let's go ahead and go to our next slide. So if we're going to use Boyle's law, P1 V1 equals P2 V2, what is our initial pressure? 748 torr. So 748 torr. Our initial volume, and sorry, I got to keep going back here because it's on this other slide. Our initial volume is 10.3 liters. 10.3 liters. Our final pressure, the pressure is increased to 1.88 atmospheres. And before I even write it down, I go, oops, that doesn't work, because here I have torr, here it wants me to write down atmospheres, and I know those aren't going to cancel. So I'm going to take, using a calculator here, I'm going to take 1.88, and then doing the math, I'm going to multiply by 760, then I would divide by 1, and that is equal to 1,400, and let's round to 3 significant figures, 1,430 torr, and then obviously V2. Let's come back here real quick. Calculate the volume the gas will occupy. So they're asking us to find the final volume. Okay, so now we've got everything that we need. Now we can just solve for V2. So let's divide both sides by 1,430 torr. And then we can go to our calculator. So this is basically just a review. This is just a Boyle's law problem. So 748 times 10.3 divided by 1,430 gives me a final volume. Here they cancel. Torrs cancel. I get a final answer of 5.39 liters. And that is my answer for that problem. Okay, let's look at the second question now. It says, calculate the volume the gas will occupy if the temperature is increased to 165 while the pressure is held constant. So again, let's come back to our original equation. P1 V1 over T1 equals P2 V2 over T2. And in this case, they're telling us that the pressure is going to be constant. So in this case, the pressure is just out. So now it's just V1 over T1 equals V2 over T2. So now this is just a Charles law type problem. So our initial volume is what we're looking for. So our initial volume is our 10.3 liters. So 10.3 liters divided by our initial temperature, 23 degrees Celsius, get rid of that, 296 Kelvin, adding 273, 296 Kelvin is equal to our final volume. We don't know. Again, they're asking us to calculate the volume. So V2 will be our unknown, and our final temperature is 165. Get rid of that. 273 plus 165 is, I think that's 438 Kelvin. And now we solve for V2. So just like always with Charles' law, we're going to cross multiply. When we cross multiply, we're going to take 10.3 and multiply it by 438. And that'll give us a number on the left-hand side. Then on the right-hand side, we're going to take 296 divided by V2, and then we're going to end up dividing by 296, and I get a final volume equal to, I'm looking here, all of these have 3 significant figures, 15.2 liters as my final answer. Okay, now our third question says calculate the pressure of the gas if the temperature increases to 65 and the volume decreases to 9.2. Now, here's a good example of how do I know what equation to use? Because now we're up to 3, and unfortunately, we're not done. We've got Boyle's law. We've got Charles' law. And now we have the combined gas law, or the general gas law. And how do you know which one to use? How did I know in the first one to use Boyle's law, let's say? Well, because when you read it, if the temperature doesn't change, you have to be able to understand that this equation changes. If there's no temperature involved, you use the equation that doesn't have temperature. On the second equation, when they tell you the pressure is held constant, that's telling you take that pressure out, so it's just involving volume and temperature. In the third equation, how do you know, or this third question, how do we know that we have to use the combined gas law as opposed to Boyle's law or Charles' law? Because two things are changing. The temperature was 23, now it's 65. The volume was 10.3, now it's 9.2. Anytime you have two of your variables changing, that is when you'll be using this combined gas law. So maybe that's something that you need to write down, that's when you know to use the combined gas law, is when two of your variables change. So we're going to have the whole thing here, P1 V1 over T1 equals P2 V2 over T2. So now to be able to solve this problem, we have to know 5 of the 6 variables. Let's make sure that we do. So P1, our initial pressure, was 748 torr. Let me go ahead and erase all this so I can use it again. So our initial pressure, 748 torr. Times our initial volume. Our initial volume was 10.3 liters. That's a decimal point there, sorry. And we're going to divide that by the initial temperature, which is, again, in Celsius, it was 296 Kelvin. So over 296 Kelvin is equal to our final pressure, our P2. So let's check in the question. They're asking us for that. Calculate the pressure. So that's our unknown. So P2 times our final volume. Final volume is 9.2 liters. And then our final temperature is, again, 65 plus 273 is 338 Kelvin. So 338 K. Now, just like with Charles' law, don't let all these numbers mess with you. Just like Charles' law, we do the same thing. All that we're going to do is we're going to cross multiply. We're going to move that up to there, and we're going to move that up to there. So overall, we're going to have, and I'm going to see if I can fit this all in here, 748 torr times 10.3 liters times 338 Kelvin equals P2 times 9.2 liters times 296 Kelvin. Okay, so it's a very similar process to what we did with Charles' law when we cross multiply. Because now, once we've cross multiplied, now to get P2 by itself, we're going to divide each of these. So both sides, we're going to divide by 9.2 liters and then by 296 Kelvin. 9.2 liters, 296 Kelvin. And then obviously on our right-hand side, everything cancels. On our left-hand side, the kelvins cancel, the liters cancel, and all we have left is what they're asking us for, which is torr. So now when we do the math, let's make sure we're all putting this in the calculator correctly. Everything on the top, hit multiply. everything on the bottom, hit divide. So that's, if you remember that, that'll make it really, really easy. So I'm going to go 748 times 10.3 times 338 divided by 9.2, careful here, divided by 296. And I get a final pressure equal to 956 torr. And that's my final answer. Once I've done all of that, I've canceled everything. I know that I've done the problem correctly. Then I just have to check and make sure I've put my numbers in the calculator correctly. And that is how you use the combined gas law.